Best local AI model is the wrong question. And asking it wrong is why so many people's first local AI experience ends with a frozen laptop and a deleted folder. Here's what actually happens. Someone watches a video about an amazing new open model, downloads it, waits 40 minutes, launches it, and their machine grinds to a halt. The fans scream, and the first token arrives sometime next Tuesday. They conclude local AI isn't ready, and go back to paying subscriptions. And the whole disaster happened because nobody told them the only question that matters. Not what's the best model, what's the best model for the machine I actually own? That's this video. A complete map of local AI in 2026. Organized the only way that makes sense, by your hardware. 5 tiers from a machine with no GPU at all to the absolute ceiling of what's possible today. For every tier, what to run, what it's genuinely good at, the coding pick specifically, and the honest limits. Plus the 3 rules at the start that let you evaluate any model yourself, including every model released after this video. And the 1 trick that tells you in 10 seconds whether a model actually fits your machine. By the end, you won't just have a pick, you'll have the framework. Let's build it. First, the 3 rules. Master these 3 ideas, and every model release for the rest of the year becomes instantly legible to you. This is the most valuable 5 minutes in the video. Rule 1, the memory rule. A model's real appetite is memory, RAM, or GPU memory, or on a Mac, unified memory. The working rule of thumb at the standard 4-bit compression most local tools use. A model needs roughly half its parameter count in gigabytes. A 7 billion parameter model wants around 4 to 5 gigabytes. A 14B wants 8 to 9. A 32B wants around 20. Whatever memory your machine has, the model plus your operating system, plus your browser all have to fit, which is why an 8 gigabyte laptop tops out around 7B models. 16 gigabytes gets you comfortably to 14, and 24 plus opens the 30B class. Burn that into memory, and you can size any model against any machine in your head forever. Rule 2, active versus total, the MoE loophole. This is the rule that changed everything in the last year. Modern big models are mixtures of experts. A huge total parameter count, but only a small slice. The active parameters actually fires for each token. Total parameters determine how much memory you need to hold the model. Active parameters determine how much compute each token costs, which is to say, speed. So when you see 118 billion parameters, 8 billion active, read it as, needs big memory, runs like a small model. That loophole is the entire reason the top tiers of this guide exist, and it's why the most exciting local models of 2026 have spec sheets that look like typos. Rule 3, quantization in 1 minute. Models are trained in high precision, 16 bits per number. Quantization stores those numbers in fewer bits, 8, 5, 4, shrinking the file and the memory footprint dramatically. At 4-bit, quality loss is small for most models and most uses. It's the standard, and it's what the memory rule above assumes. Push below 4-bit, 3, 2, and degradation gets real and noticeable. So when you see Q4 in a file name, that's the sweet spot. Q2 is desperation. And some 2026 models are now trained knowing they'll live at 4-bit quantization-aware training, which makes their 4-bit versions nearly lossless. That's the direction everything is heading. 3 rules, memory equals half the params, active params equal speed. 4-bit is the sweet spot. Now let's climb the ladder. Tier 0, no GPU, 8 gigabytes of RAM. The floor, an ordinary laptop, a mini PC, the machine you already own. Let's set expectations honestly, because this tier is both more capable than skeptics think and more limited than hype suggests. You're running models in the 3 to 8 billion parameter class, Llama 3.2, the small Kuwen models, Google's Gemma line. On pure CPU, you'll see something like reading speed, roughly 10 tokens a second, which feels slow if you expect instant, and perfectly fine if you treat it like a thoughtful colleague typing. What are these genuinely good for? More than people think, summarizing documents, drafting and rewriting emails, answering general questions, explaining code, simple scripts, translation, brainstorming, the daily driver tasks that make up most of what most people actually use AI for. What they're not, deep multi-step reasoning, big coding tasks across many files, or anything where subtle judgment matters. A 7B model is a sharp assistant, not a senior engineer. The coding pick at this tier, a small QN coding variant. The small coding models have improved shockingly fast, and for single-file scripts, explanations, and autocomplete style help, they're honestly useful. The move that makes this tier shine. Pair the small model with narrow, well-defined tasks. Small models fail when you ask for judgment. They excel when you ask for work. And one honest subnote, if your machine is this tier and you're on a desktop, the single best upgrade per dollar in all of local AI is cheap RAM. 16 gigabytes changes your life here. Tier 1, 16 gigabytes. The comfort zone, where most decent laptops and desktops live, and where local AI stops feeling like a demo. The class here is 13 to 14 billion parameters, and the step up from 7BB is bigger than the numbers suggest. noticeably better reasoning, longer coherent outputs, fewer facepalm mistakes. The all-rounder pick, a QN14B. It's the reliable workhorse of this tier, strong at general work, genuinely competent at code, multilingual, well-supported everywhere. Now the Mac note, because this is where Apple owners get their surprise. Apple Silicon uses unified memory, CPU and GPU share one pool, which means a 16GB MacBook Air punches above a Windows laptop with a small dedicated GPU, and a 24 or 32GB Mac quietly plays in the next tier up. If you own an M-series Mac, mentally promote yourself half a tier. The Mac ecosystem Ollama LM Studio llama.cpp with Metal is superbly optimized now. Coding pick at 16GB. The 14B coding variants handle real work, multi-hundred-line files, refactors, test writing at the level of a solid junior developer who occasionally needs correcting. With a GPU or Apple Silicon pushing 30 to 60 tokens a second, the experience is genuinely fluid. This is the tier where a meaningful number of people can honestly cancel a subscription for their routine AI use and feel nothing. Tier 2, 24GB of GPU memory, or a 32 to 48GB Mac. The Enthusiast tier, an RTX 3090 or 4090, or a well-spec'd Mac Studio, and the tier where I don't need the cloud for this starts being simply true. The class, 27 to 32 billion parameters, and 2026 has been astonishing here. The headline resident is Bonsai 27-B, the model we covered running entirely on a phone, which at desktop scale, unconstrained, is a wonderfully capable daily model. Alongside it, QN's 27 and 32B class models, which the whole community leans on for a reason. At 32 billion parameters, you're getting reasoning quality that would have been Frontier adjacent 18 months ago, running at conversational speed on hardware a gamer might already own. What changes at this tier isn't just quality, it's trust radius. The tasks you'll comfortably hand a 32B expand into real work. Multi-file coding tasks, long document analysis, serious writing, agent workflows with tools. Mistakes still happen, but they're the kind a quick review catches, not the kind that quietly ruins an afternoon. Coding pick, the 32B coding models, full stop. This is the current sweet spot of local coding per dollar of hardware. And a workflow note that compounds everything. This is the tier where pairing a local model with the agent tooling we cover on this channel, a coding CLI, a review tool, proper skills, turns a model into a setup. The model is the engine, the tooling is the car. Tier 3, the Workstation class. 48 to a few hundred gigabytes of memory, a DGX Spark class desktop box, a multi-GPU rig, a top-end Mac Studio. Serious hardware, undeniably, but desk hardware, not data center hardware. And this tier is where 2026 got genuinely wild, because Rule 2, the MOE loophole, kicks in with full force. 2 releases this month redefined what this tier can do, and regular viewers know both. First, Laguna S 2.1, 118 billion total parameters, only about 8 billion active. At 4-bit, it runs on a single DGX Spark. Read that against the rules. The memory footprint of a big model, the per-token cost of an 8B. On the published benchmarks vendor published, with third-party corroboration on several, it trades blows with models many times its size on agentic coding. A Frontier-adjacent coding model, on one box, under your desk, with a permissive license. Second, DeepSeek V4 Flash, 284 billion total, 13 billion active, and at 4-bit precision, it's genuinely viable on high-end consumer setups. Community deployments on Spark-class hardware were documented within days of release. A 1 million token context window, MIT license. Understand what this tier now represents because it's historically new. For roughly the cost of a used car, a lot of money, but a knowable amount of money, an individual or a small team can run coding models that compete with the Frontier APIs privately with 0 per token cost forever. 18 months ago, that sentence was science fiction. The coding pick here is genuinely a coin flip between Laguna and V4 Flash. Laguna if agentic coding benchmarks sway you, V4 Flash if you want the giant context and the absolute lowest cost lineage. And honestly, at this tier, run both and let your own codebase vote. Tier 4, the ceiling. What's possible as distinct from what's practical because knowing where the ceiling is tells you where the whole field is going. 2 residents. First, GLM 5.2, 744 billion parameters. MIT licensed, which should be impossible outside a server room, except for the SSD streaming trick. Because it's a sparse MO, a tool like Calibri keeps a small core resident and streams the active experts off a fast SSD on demand. That's how a 744B model ran on an ordinary laptop, no GPU, in the video that this channel is probably best known for. Slowly? Yes. Actually working? Also yes. If you have a fast SSD and patience, the ceiling is available to you today at almost any hardware tier as an experience and an education, if not a daily driver. And second, as of this week, Kimi K3 2.8 trillion parameters, the largest open model ever, waits now public. Full K3 is server hardware, period. We made a whole video on exactly what it takes. But it earns its place on this map for one reason: 16 of 896 experts active. The most extreme sparsity ratio yet, which makes it the great open question for the streaming crowd. Whether K3 can be coaxed onto Enthusiast hardware through streaming is the frontier experiment in local AI right now. And this comment section, like the last one, is invited to report findings. So that's the ladder. Let me give you the whole map in 60 seconds because this recap is the screenshot moment. No GPU, 8 gigs, small llama, QN, or Gemma, daily tasks at reading speed, pair small models with narrow jobs, 16 gigs, QN 14, B all-rounder, 14B coder for real work. Mac owners promote yourselves half a tier. 24 plus GPU or Big Mac. The 27 to 32B class, Bonsai and QN, the local coding sweet spot. Add agent tooling, and it becomes a setup, not a model. Workstation class, the MOE monsters, Laguna S 2.1 and DeepSeek V4 Flash, Frontier adjacent coding on one box, no meter running. And the ceiling, GLM 5.2 by SSD streaming today. K3 streaming as the open experiment. That's the entire local AI landscape of 2026 in 5 sentences. Now the question that naturally follows, should you buy hardware for this? And if so, what? 3 honest answers for 3 budgets. Budget 0, spend nothing. Run the best model your current tier allows, get fluent with the tools, and let the escalator work. The models at your tier will be meaningfully better in 3 months without you touching your wallet. Most people should start here, and many should stay here. Budget modest. The 2 best value moves in local AI in order. If you're on a desktop at tier 0, cheap RAM to 16 or 32 gigabytes is the biggest jump per dollar in this entire video. And if you want GPU acceleration, the community's open secret remains the used previous generation 24 gigabyte cards. An RTX 3090 pulled from a gaming rig delivers tier 2 local AI at a fraction of new card prices, and its 24 gigabytes of memory matter, far more than its age. Memory capacity beats GPU generation for this workload, almost every time. Budget serious. You're choosing between a high memory Mac and a Spark class AI workstation, and the honest split is this: the Mac is the better general machine that happens to be excellent at local AI, with unified memory doing heavy lifting and a silent, efficient box on your desk. The dedicated AI workstation is the better local AI machine, period. It's what unlocks Tier 3's MOE monsters at full speed. If local models are a feature of your life, buy the Mac. If they're the point, buy the workstation. And whichever you buy, prioritize memory capacity first, memory bandwidth second, and raw compute third. That ordering is the entire buying guide in one sentence. Now, before the honest limits, the practical bit, how to actually verify a model fits, instead of finding out the bad way. And since local coding is the reason half of you are here, let me assemble the full setup, not just the model, but the working rig, per tier using pieces this channel has covered individually. Tier 1, 16 gigabytes, a 14B coder as the engine, driven through a coding CLI, with our free code review tool from the Alibaba video pointed at the same local model. A complete write and review loop, where not one token leaves your machine. Total monthly cost, 0. Tier 2, same shape, upgraded engine, the 32B coder, plus proper skills from our skills tutorial in coding your conventions, and the design language skill if you build UIs. At this tier, the local setup handles a genuinely large share of a working developer's week. Tier 3, Laguna or V4 Flash as the engine. And now the interesting question inverts. Instead of can local handle this task, it becomes which rare tasks still justify sending anything to a paid API at all. That's the complete stack. Engine per your tier. Agent, CLI, review loop, skills. Every piece free. Every piece covered in depth on this channel. All of it linked below by tier. The 10-second truth teller. When you load a model in Ollama or llama.cpp, watch the startup output. It tells you exactly how many of the model's layers loaded onto your GPU versus spilling to CPU. Most or all layers on GPU. You're golden, it'll fly. Half or fewer, the model is too big for your memory, and it will crawl. That single readout replaces all guesswork. The method, start one size below, where the memory rule says you can go confirm it's fast, then step up. Upgrading is one command. Unfreezing a swamped laptop is an afternoon. And for tools, start with Ollama. Our full tutorial covers it end to end. Graduate to LM Studio if you want a friendly interface with fine-grained control, and reach for VLLM when you're serving a model to more than just yourself. While we're being concrete, calibrate your speed expectations, because it spans a huge range, and knowing what's normal saves you from misdiagnosing a healthy setup. The rough bands: pure CPU on a small model, around 10 tokens a second reading pace, fine for chat, tedious for long generations. A properly GPU-loaded model at its right tier, 30 to 60 plus tokens a second faster than you read, which is where local AI stops feeling local. The Mo workstation monsters, tuned comfortably usable for agent work, where the model reasons and calls tools in bursts rather than streaming pros at you. And SSD stream giants at the ceiling. Seconds per token, not tokens per second, a different sport measured in it worked at all. If your numbers are wildly below your band, it's almost always the layers readout telling you the model spilled to CPU. Drop one size and watch it snap into place. Before the limits, 4 rapid-fire questions I know are coming, because they always come. What about long context? The underexplained gotcha. Context eats memory on top of the model. The conversation's working memory. The KV cache grows with every token you feed in. So a model that fits comfortably with a short prompt can blow past your memory with 100,000 tokens of context. If long documents or big code bases are your use case, budget several extra gigabytes beyond the memory rule. Keep contexts trimmed or watch this space, because the cache compression math we covered in our TurboQuant video is exactly the technology racing to fix this, and it's already landing in the local toolchain. Can I fine-tune at my tier? Short answer, from tier 2 upward, yes. Lightweight adapter methods make tuning a 7 to 14B model on a 24GB card genuinely practical, and it's the gateway to a model that speaks your domain. Tier 0 and 1. Run models, don't train them. Use a strong system prompt and good context instead. It gets you 80% of the benefit for 0% of the VRAM. Can I run 2 models at once? Yes. And it's underrated. A small, fast model for the routine and a big one loaded on demand is a genuinely great local setup. The same 80-20 split we apply to everything, running entirely on your desk. The tools handle model swapping gracefully now. Keeping both resident simultaneously just means adding their memory footprints per the rule. And what about power, heat, and noise? Real considerations at tier 2 and above. A GPU under sustained inference load draws real wattage and makes real noise. And if your machine lives in your bedroom, that matters. It's a big part of why the Mac Path and the purpose-built quiet AI boxes have such devoted followings. Tokens per second per decibel is a spec sheet nobody prints and everyone eventually cares about. Okay, the honest limits. 4 of them, because this guide would be an advertisement without them. 1. The frontier gap is real. The very best closed models, the top-tier APIs, are still better than anything on this list at the hardest tasks. Subtle reasoning, huge ambiguous problems. The last 5% of polish, the gap has narrowed dramatically. We've documented that narrowing all month, but it exists, and pretending otherwise would make everything else in this video less credible. The honest framing is the 80-20. We always come back to local for the daily 80%, private, free, unlimited, and the paid frontier for the 20% that genuinely needs it. On that split, most individuals' AI spending approaches 0, which is rather the point. 2. Benchmarks are a starting line, not a verdict. Several numbers behind this guide are vendor published, where third parties have verified I've said so. And as we covered in the K3 video, even which agent harness runs a test can swing coding scores by double digits. The only benchmark that finally matters is a week with your own work. This guide gets you to the right shortlist, your own use picks the winner. 3. This list has a shelf life, and that's by design. The specific models named here will be challenged within months. That's how 2026 works. But notice what doesn't expire. The tiers, the 3 rules, the truth teller trick. Learn the framework and every future release slots itself into your map on site. When a new model drops, you'll read X billion total, Y active 4-bit, and know instantly before any reviewer tells you whether it's yours. And 4, memory bandwidth matters, not just capacity. 2 machines with the same gigabytes can run the same model at very different speeds, depending on how fast that memory is. It's the fine print behind why Apple Silicon and Workstation GPUs outperform their raw spec. If you're buying hardware for local AI, look at bandwidth numbers, not just capacity. Future you will thank present you. Step back, and here's the pattern hiding in this whole video. Walk the timeline of just this year, a 27B running on a phone, a 744B streaming onto a laptop, a 118B on a single desktop box, a 284B at home, and this week, the weights of a 2.8 trillion parameter model, free, downloadable, permanent. Every few weeks, a tier that was impossible became Enthusiast, and a tier that was Enthusiast became normal. The ladder you just climbed isn't static, it's an escalator, and it only moves one direction. The best local model for your hardware next year will embarrass everything in this video, which means the real advice isn't any single pick. It's get on the escalator now at whatever tier you own, because the skills compound and the hardware you have keeps getting more capable by standing still. So here's my question, and this time it's also an offer, so I'll pin it below. Post your exact hardware in the comments, RAM, GPU, or Mac chip, and what you want to use AI for, and I'll reply with your specific pick from this guide. Every machine, every budget, genuinely. And the setups I see most often become the follow-up deep dives, so you're not just getting a recommendation, you're voting on what this channel builds next. Every link, the models by tier, the tools, the hardware checking commands, and our full tutorials on Ollama, Colibri, Laguna, DeepSeek V4, and the K3 weights is in the description. Organized by tier so you can jump straight to yours. That's the standard on this channel. The real, complete, honest guide in plain English. If you'd rather own your AI than rent it, subscribe. That's what we do here every single day. I'll see you in the next one.